Well, the purpose of this module is to do a basic review of engineering math that's relevant not just for this class, but many other classes in engineering. First concept we'll look at is derivative. The second one is look at the principle of dimensional consistency. The third one is a notion of differentials. I'm pretty certain that all of these are concepts that you've been exposed to, but perhaps not in the context of how I might present it. So that's the only slight difference, perhaps. Let's take the concept of a derivative, right? All of you are familiar with taking a function y, differentiating with respect to the function x, is formally defined as a limit as some increment delta x approaches 0 of y evaluated at x plus delta x minus y evaluated at x divided by delta x, right? This is a formal definition that you learn in calculus. The point I want to make is typically dy dx would also have units associated with that. For instance, if y were distance and if x is a unit of time, then the quantity dy dx will have the appropriate units. And the way I would denote that is, so this symbol means the dimensions of. So you want to read this as dimensions of whatever is inside the parentheses. So the dimensions of dy dx is the dimension of y divided by the dimension of x, which in this particular example could be distance, which I will call length, divided by time. Okay. Units are quantities that are used in order to quantify dimensions. So for instance, in the case of L for length, I might use a metric system of units where L might be measured in meters, right? And likewise, T is a dimension which I might use seconds, units of seconds to measure that, right? So I'm making a distinction between dimensions and units. And the way to think about it is dimensions are fairly general and units are quite specific, right? So whether it's dimensions, I might just say length or mass. And in the case of units, I might explicitly state that I'm talking about a unit of length or a unit of a kilogram or a unit of a gram, as the case may be. So that's the distinction between dimensions and units. So that's the notion of derivative, and typically in calculus you probably don't pay too much attention to the units of the quantities that are involved in writing derivatives, but it's very important in engineering to remember that these quantities do have dimensions. All right, so the next notion is the notion of principle of dimensional consistency, right? So the principle of dimensional consistency, which is articulated in the notes, is basically saying you can only add apples to apples in a nutshell, right? Dimensionless consistency. I take that back as the principle of dimensional consistency. Basically, you can only add apples to apples, as I said. So if you have an equation, the equation can be an algebraic equation, a plus b plus c equals d minus e. Basically, it's saying every term in this equation should have the same set of units, right, or the same dimensions. So in other words, the dimensions of A have to equal the dimension of B, have to equal the dimension of D, etc. Okay. And sometimes knowing this is very useful when you encounter an equation. And these equations can be algebraic. They could also be a differential equation. Okay, so I can have dy over dx equals minus alpha y as an example, right? So in this case, the dimensions of dy over dx have to equal the dimensions of alpha times y. Okay, let's take a specific example. Let's say y, the dimensions of y is length, and let's assume the dimensions of x is time, just like before, right? So the dimension of dy dx would be length divided by time, and which should also be the dimensions of alpha times y. Okay, But we know the dimensions of y, as assumed here, is length. So this implies the dimensions of alpha have to be 1 over time, right? So you have no choice, but alpha should have the units or the dimensions of 1 over time. Okay, so it's very important to keep that in mind. If you read the engineering math summary notes, there are other specific examples that are given. For instance, an equation that arises in fluid mechanics later this semester is P plus half rho V squared plus rho GH is a constant. P is pressure, rho is density, V is velocity, G is acceleration due to gravity. And if you read the discussion, basically the dimensions of P, the dimensions of half rho V squared, the dimensions of rho GH all have to equal each other, okay? And which will have to equal the dimensions of the constant, by the way, on the right hand side of the expression above, okay? That's one aspect of the principle of dimensional consistency. Another aspect, which is probably less emphasized in other classes, perhaps even in your physics classes, is that in addition to differential equations, when you have functions such as cosine or exponential or tangent, so these are called, for fancy word, transcendental functions. Okay, these are called transcendental functions, or even log, etc. The arguments of all of these quantities have to be dimensionless. So suppose I have an expression exponential of minus alpha times t. Okay, what this principle of dimensional consistency tells us is this alpha t should have no dimensions. So alpha t should be a dimensionless quantity, right? So for example, if t is time, then alpha has to have dimensions of 1 over time, so that the product of those two quantities will be a dimensionless quantity. Similarly, when you have something that looks like this, cosine of omega t, that appears in an expression, the dimensions of omega t have to be dimensionless. So the way to think about that is I would write that as omega t dimensions equals 1. So if t, for instance, is time, then this implies the dimensions of omega have to be 1 over time. Okay, so omega may have a term like frequency or something, t is time. And it's important to remember that if you construct an equation and if you get a result and you have something which is cosine of L squared and L has the units of length, you know you've made a fundamental mistake in your problem, because no cosine of L squared is not allowed, right? Because this has dimensions of length raised to the power 2, and the argument of the cosine, as per the principle of dimensional consistency, says that we cannot have any units associated with it or any dimensions associated with these arguments, right? So what I mean by argument is whatever is inside the cosine or whatever inside the exponential or the log, those kinds of functions. All right, so that's the second concept, which is very important. The third concept is the notion of differentials, which you study again in a basic calculus class. But again, I want to emphasize a few things that are relevant. So I can think of dy dx as dy over dx. I'm sorry. What I meant to say was I can think of dy, the change in y, as the rate of change of y with respect to x, that is dy dx, multiplied by dx. Okay. So this allows me to obtain the change in y. This is the rate of which y changes with respect to changes in x. This is the amount that x changes by, and everything has to be dimensionally correct, right? So the dimensions of dy have to equal the dimensions of dy dx times the dimension of x. Okay. Often in this concept comes in handy. For instance, if let's say this is my x-axis, this is my y-axis, and I have a function that might look like this, let's say. So this is y at a certain location x, And I may ask the question, how much does y change by if x changes just a little bit? So if x goes from, let's say, x to x plus dx over 2, then the question is, what does y change by? And the way you would express that is the change in y, dy, would be the rate of change of y with respect to x. And in this case, the change in x is simply dx over 2. So if I go a distance dx over 2, the new value of y would be this, and this difference is the quantity dy. Okay, so the notion of differentials also comes in handy. We will see that as soon as in the second module, which begins with chapter 2. So I hope these concepts are useful. I encourage you to read this PDF document in more detail. It'll probably be helpful for a number of other classes as well.